Hello everyone. So this is Shivendra Upadhyay and welcome to this session. We are going to talk about, data science and logistic regression demo going forward. So let's begin. So I'm going to just give a brief overview about our today's agenda, introduction to data science. Then we are going to, talk in detail about how data science lifecycle works. Then what is the regression? This is one of the machine learning technique or algorithm. And then what is logistic regression and why we want to use logistic regression, and plus the details of it and the comparison between linear regression and logistic regression. And also I will provide you a quick hands-on demo using Python for logistic regression. So this is the agenda for today's demo. So first part we'll be covering about data science. What is data science actually? So in general, like you could see, data science is the process of extracting knowledge and insight from data by using scientific methods. So basically in nutshell, it's a combination of any coding or programming language to implement your logic or models or methods. So we call models, these are also, programmatical framework which have been developed by people in open network or community, which are readily available for use and free of cost. And you can optimize or reuse the functionality being developed like any other software package. Plus it leverages the statistics, like there are multiple statistical concept and methodology behind the implementation of these machine learning models, which are at the heart of all this model. So to get the optimum result, to make multiple or informed comparison, plus then you have to wed this together with the business need or business outcome to drive growth and revenue. Otherwise everything will be in vain if you are not aligning your overall data science objective and implementation with the business need. So it is a, I would say, tremendous combination of highly intensive knowledge of statistics, maths, some amount of programming, and plus models which have been already developed, plus you can develop your vanilla model also with the business to drive growth in business, like Amazon, Facebook, and Google, these company too, or any other startup like Swiggy or Flipkart. They are all leveraging data science in background. And also one key thing is data is the, I would say, a critical or crucial factor for any data science practice. Any kind of data, be it business, BFSI, banking domain, or manufacturing domain, or telecom domain, or healthcare domain. Data is quite critical. So moving forward, as we discuss, data science also known as data driven science, as I told you, because data is at the heart of everything. We are going to play with the data, draw different insight by applying different statistical process algorithm, which I told you initially, to draw various insights, to understand how a particular set of variables are going to impact your sales or revenue for maybe a company like Tesla or maybe a company like Apple, which are the factors are impacting the sales of a new iPhone or sales of new maybe MacBook Pro or those kind of things. So to understand those hidden inside, we apply the collection or set of this I would say algorithm and already defined processes plus statistical technique. I would say unravel the hidden insights which are not obvious to even to the brilliance of mind. So these techniques and algorithm help us to draw this insight. Okay, so this is how data science works in nutshell or in background, and it also leverages all the cutting edge technologies and tools like big data and cloud, AWS, GCP, or Microsoft Azure, and any other native cloud solution also to draw the insights for huge amount of data at scale in maybe in few microsecond or nanosecond according to the business needs. This is a great thing about data science. So moving forward, so let's see the I would say high level data life cycle. So this is how you deal with the data. To you start with a normal raw data set. It could be anything from healthcare or maybe automobile or maybe some retail division, and you will try to understand the data. What kind of features are there? What kind of attributes are there? Suppose you are dealing with say retail industry, so maybe sales, maybe product category, maybe item category, those kind of feature you will look in. Then you will try to find out how much quantity of data you have. The quality of data also you will check, whether how much data is maybe missing, and which column have most number of, I would say, records, and what are the variety of data, if they have categorical data or nominal data or ordinal data. This kind of variation you will check, you know. Then afterwards you will go for data preparation process. And data preparation process will be according to your, business goal and objective. You will transform the data via using any, coding technique or coding language, maybe Python, R, or Java, whichever you prefer, and you'll transform the data according to your needs. Maybe creating new columns or new feature, maybe dropping few column of feature, maybe creating new aggregation, like combining two columns or taking the sum or max or such technique you will apply, and maybe you will fill out missing value, implementing or filling in some values from your domain understanding or business understanding. So it depends how you are going to deal with the data from business to business, and from different subject to subjects. So it is quite subjective, but there are some standard practices also. Afterwards, you according to your data, whether it's numerical data, or whether it's unstructured data, or whether you are dealing with images, or whether you are dealing with IoT sensor data, or maybe time related data, you will evaluate your models. There are tons of model out there, right? So either you are going to use normal statistical model. Maybe for time series data you can go with ARIMA modeling, SARIMA, or LSTM model. Deep learning models are there for time series modeling. Or maybe with normal numerical data you can go with regression modeling, where we want to predict value of a product, or maybe inventory capacity planning you want to do. You can go with logistic regression, sorry, normal linear regression, or S support vector regression, or maybe random forest regression also. So with the or so these kind of technique are quite neatly related and tied up with your data set and problem also. But from your domain understanding and your past experience, you start getting the intuition. And again, you have to experiment with multiple model. You cannot simply decide on a simple model. Like usually for classification problem, people go with random forest, because that is very easy to build, plus it is very easy to explain also, for a normal user, compared to support vector machine or logistic regression. So this is how it works. Then you'll start your model building exercise. So then you'll start your model building exercise, like dividing your data into training, validation, and test data sets. You'll build your model, do multiple rounds of model building, and test your model's performance. Okay, and once you are satisfied that your model is performing, I would say, consistently and giving you an optimal results, and you have the confidence and you have checked every matrices, then you will go on operationalizing, maybe on cloud, or basically deploying your model on real time platforms like cloud or in-house servers, or maybe integrating with existing websites or apps via using APIs like REST API or fast APIs. So there are multiple techniques. You can use web-based methods like Flask is there, or Django is there. These are like web-based methods or framework provided by Python. So solely depend on your need or your business infrastructure and hardware support. And the final things, which is quite critical and crucial for any data science project, how you communicate your findings or solutions KPI with the end user. End user could be maybe your clients, maybe a layman person. Maybe you have developed an app. How you communicate the results of your finding, right? So for that, you can create a website or integrate your code in backend again with the APIs and all those things. Or either you can use there are multiple visualization tools are out there like Tableau, Power BI, or ClickView, or Plotly. Dash is there, or R Shiny is there. So in terms of multiple charts, maybe bar chart, pie charts, scatter plots, and and HTML pages can also be created. So there are multiple ways, and you have to communicate these findings or whatever your model is able to, I would say, infer in a very simplistic terms, because a user or business end user cannot understand your codes and interpretation of model. So you have to obviously integrate with a front end solution. So this is an end-to-end life cycle of a data science product or framework. So this is how it works. So I hope it gives you a I would say meaningful glimpse into a data science or data scientists work, how they go over their work from getting the data, developing a model, data transformation, deploying the model on customer premise or maybe on clouds, and then communicating the result or presenting their, I would say, end work or end product to the end user. So this is how it is being done in nutshell. So let's move forward. So, which are the main programming languages for data science, which are vastly used across the world? I would say in recent few years, like there is R, Python, SAS is there, Java, MATLAB, and SQL. SQL is quite useful for any data scientist to do, I would say, a very quick and dirty analysis. So SQL is quite handy. R has its own pro and con. Plus SAS is there, and MATLAB is also there. But MATLAB you require quite a, it's a costly software, and plus Java it's an open source language. But Python is the dominant among all. So Python is leading the way, and this is most famous and across the industry, and this is being used widely by most of the companies now. And R is also there. R is really good for statistical modeling, like I would say time series data or IoT sensor data, and I would say in forex trading and these scenario, like hedge fund is there, are they have really good packages. MATLAB also works really well over there. MATLAB works really well where you have a huge amount of calculation, and even minute granularity of data matters, like I would say in space, time traveling and calculation about galaxies and those kind of stuff. Their MATLAB works really well in those kind of calculation. But Python is the leader in machine learning domain currently. So what is regression? This is one of the technique which we also called it linear regression or OLS regression. So there are orderly least square regression. So there are multiple types of regression also, but here we are going to talk about normal regression, a linear regression technique. So linear regression is a predictive modeling technique. Why we call it predictive modeling? Suppose you have some amount of data. Okay, let's take example of a car company. Okay, and while looking at the previous 3 year or 5 year sell, you want to determine which model's car you should stock up most for coming year. Hence, you can cater to the customer's demand in time, Hence customer will be satisfied in turn, and your revenue will shoot up through the roof, right? Because if wait time is longer, it may happen you lose revenue and customer, right? And you have quite unsatisfactory and grumpy customer, which you obviously don't want. So you want to predict the sale of a particular car or sale of a particular model while looking at previous 3 or 4 years data. So you want to predict sale of a car while looking multiple set of features or values, okay, from past data. So sale of a car is your dependent variable, and multiple set of data or multiple features from previous 3 or 4 years are going to be your independent variables, on which, on the variation of their combination of values, your dependent variable or target variable, which is sale of a car in next year, is going to respond. So this is how it works in nutshell. You have a combination of independent variable which will drive your dependent or target variable. So target variable will be sale of the car. Okay. So you could see in a normal form, it estimates the relationship between independent target and independent variable predictor variable. Okay. And most of the times in linear regression, the relationship is supposed to be linear. So what is linear and non-linear? When I say linear, means when independent variable or predictor variables values changes positively, it is going to impact the target or dependent variable value in response to that positively as well. Suppose it increases by 100 or 200, so same amount of impact or effect is going to be reflected on your dependent or target variable, or vice versa. If it decreases by some amount, so similar amount of impact is going to be reflected on your target predictor variable. So this is how linear relationships are defined. Or what is non-linear relationship? Non-linear relationship is if you cannot directly relate this or model a relationship between two variables. Maybe like sentiment analysis or unstructured data, right? Suppose you are posting about some article or something online, right? Or maybe a product review in Amazon. If you give positive review, it doesn't mean the sale is going to be increase. Sale is going to increase for that product, and that also doesn't mean it's going to decrease also. So there you don't have a direct linear relationship to determine whether your positive comment or feedback is going to impact and how it is going to impact the sale of a particular product in Amazon. you know so this, and you cannot model it in a linear fashion. You have to model it in a non-linear fashion via implementing with multiple statistical and mathematical technique. That is called non-linear relationship. So here we are talking about only a linear relationship between set of independent variables and the target or dependent variable. You could see the graph also. X-axis your independent variables. Input value may be 7. The predicted value will be 123. It's just a toy example. You could relate with anything. Maybe this is the price of a car, and this is number of cars being sold, something like that. Okay, just for an example. So I hope it gives you basic and fair idea about how regression works. So what is logistic regression and why it is needed? So logistic regression, though it's it is called logistic regression, but it's a classification technique basically. So what is exactly classification and what is regression? So classification means you are going to produce results in categorical values, like in labels, maybe 1 or 0, maybe yes or no, maybe label blue and red, or maybe car and bike, dogs and cats. These are called categorical value. And in comparison to simple linear regression, they produce result in a numerical or continuous values, like maybe 120,000 million or something like that. So that is how it is being compared. So as you could see, and mainly logistic regression we use for binary classification. So what happens? What is binary classification? Whether you want to determine it's a a particular car is going to, I would say, going to fail or not, or maybe it's going to rain or not. So these are simple binary decisions in yes or no, or maybe you're going to be able to clear your cat examination or not. It's again a binary outcome, whether you'll clear the cat or not, yes or no, right? So the outcome is going to be a categorical value or discrete value, So logistic regressions are mainly classification modeling techniques, and linear regressions are predictive modeling techniques which generate values in numerical or continuous format, like predicting the sales, predicting the revenue, those kind of things. Okay, so as I told you, linear line works in a similar fashion, and plus they generate numerical value or continuous value. And in logistic regression, we deal with categorical data which labeled categories, basically yes or no, maybe cat and dog, and failure and success, this kind of decision, which obviously you cannot model with linear regression because these are predictive modeling techniques. Okay, here actually we are talking about with the in terms of coordinates. With this, our resulting curve cannot be formulated into a single formula, hence we cannot come up with logistic, I would say, curvature or logistic regression, which is actually sigmoid is a cost function, which I'm going to talk about in the next slide. So you could see, so basic funda is linear regression works for continuous variables or numerical variables, and logistic regression works for binary variables or categorical variables. This is a funda. So you could see it's a sigmoid curve, as I told you, for logistic regression. And basically, as you most of you people might be aware of it, that logistic regression's domain is basically between 0 and 1. Like whatever value or range of values you are going to feed, it's going to generate values between 0 and 1. You could see that it ranges from 0 and 1. And how it works, suppose, and also few basic thing about logistic regression. First, it's a deterministic model. So there are two different kind of models in a normal ML space we deal with. One is deterministic, one is generative. So what is deterministic? So deterministic, you could easily see it works around in a clear threshold values or demarcation of different classes, and basically like it works on conditional probability of two classes, like class A or event A happened, so how it impacted event B, like in I would say Bayes theorem, py of x, given x, like how y is being impacted given x has already happened. That is the normal funda of Bayes theorem. So logistic regression work on that, and there are deterministic models also, like naive Bayes and k-means clustering. So in deterministic, they don't draw clear boundaries, rather than they go for joint distribution of probability of each classes. Each classes means, suppose you want to predict cat and dog, say they are going to check for the joint distribution of probability of both those classes, rather than checking on the conditional of if x is there, how y is going to reflect. And there is another difference. Deterministic or logistic regression like models, they deal really well with huge amount of data set. They work really well when you have huge amount of data, like maybe I would say 50 million, 20 million, these kind of rows. But if you have small amount of data set, for those deterministic models like naive Bayes or k-means clustering, these kind of techniques works really well. This is one of the difference. So when I was talking about clear demarcation of classes or conditional probability, so suppose basically logistic regression or sigmoid function of it will give you probability for a particular class, between 0 and 1. It cannot be negative and it cannot be more than 1, because probability ranges between 0 and 1. So suppose you are getting a probability that you are predicting it's a cat, around here, maybe 0.65 or zero point 0.7. So it is above this threshold. So you are going to say it yes, or assign it as a label of cat. Okay, yes. And suppose the value is around zero point 0.4 or zero point 0.3 or zero point 0.2, then you are going to assign the label, no, it's not a cat, it's a dog, or otherwise. So this is how it works, how the probabilistic values are generated around this threshold, and accordingly they are going to be give maximum weightage to the maximum probabilistic value according to the labels how you have passed into your model building exercise. Okay, so this is in nutshell how logistic regression works. And here, as I was talking about it, this is the cost hypothesis, not cost function. This is the hypothesis for logistic regression, and its derivation can also be done very easily. And this is the basically, main, I would say, sigmoid function is basically the hypothesis of it. And, here epsilon is a constant value of 2.778 or something like that, and y will be your outcome or independent variable. Okay, y will be your independent variable, and this will be your outcome. So this is basically looks like this, the sigmoid function. This is a distribution of sigmoid function, and it will generate values as a probability for the classes. Okay, higher the probability on the side of threshold, that label is going to be assigned. Here it will be 0 in this area. Here upward of this slope, probability value will be assigned label 1 for any given modeling or data set for logistic regression. Okay, and one more thing, logistic regression doesn't deal with non-linear data set. And second, there are techniques, there are workaround to deal with it, but in a normal logistic regression settings, you cannot feed in, I would say, non-linear data sets. To deal with non-linear data set, you have to use random forest or XGBoost, such techniques. So it's a simple comparison. You could see linear regression deal with continuous variable, as we discussed. Logistic regression deal with categorical variable like cats and dog, failure or success, yes or no. It deals with regression problems like predicting the sales, revenue, or maybe how much car you have to store as a dealer of a particular car, or maybe how much inventory you need as a supplier of a particular product. It's a logistic regression solve classification problem, whether it is going to rain or not, whether it's going to be traffic in a particular signal or not, or whether it's a cat or dog's picture, like that. And linear regression usually not always in a straight line, because there are variation of linear regression like polynomial regression, where polynomial are, are introduced to improve weight and biases to model the linear regression. And logistic regression, it's a basically deal with sigmoid curve, which is a basically hypothesis of a sigmoid function, S curve, which we discussed just now. Okay, so these are the, I would say, main differences between a linear regression, a predictive model, or logistic regression, a classification model. Okay, I hope it gives you, I would say, a great deal insight about how this, different model works and what are their main, objectives and plus usage of it. Okay, so let's implement logistic regression in a simple thing. We are going to collect the data, analyze the data, then we'll do data wrangling statistically, then we'll train and test the model and perform the accuracy check. So these are actually a very standard, I would say, process or methodology with implementing or building any statistical or machine learning or data science model. You always go through this hoop of cycle of processes, like because without data you cannot do anything. You have to analyze the data. We sometimes call it EDA, exploratory data analysis, data munging. In data wrangling, you perform to generate new features, to maybe augment the data if you have missing values, if you have insufficient values or data for few important features. You can create I would say dummy or synthetic data by using your business knowledge, or maybe using some statistical techniques are also there, which help you to generate synthetic data, which helps you in turn to do better modeling. Then you create train and test data sets. Basically, it's an internal division of 70/30, 75/25. These are recommended, maybe 80/20 also. Like suppose you have 100 rows, you divide the data into as a training data set of 80 rows and as a test data set on which model will be inferred after going through a hyperparameter tuning and training. And then you'll test the performance of that training on your test data set, because you don't have the real data, right? Because most of the time modeling or training is being done at offline mode. Okay. And at the end, you have to check where how your model is performing, otherwise there is no point going through all these hoop and trouble if you are not able to give a concrete or clear answer what is your model's performance. So there are multiple matrices which we are going to discuss how to provide a model's performance for a layman or real-time user. So that's how we are going to discuss. So hands-on exercise. So here I have already taken the liberty of picking up one diabetes data set, okay, from one of the Kaggle kernel, okay, because whatever the data I had, those were not suitable for logistic regression modeling, because data was in a way it was not going to perform really well. So I did not use that data on the purpose. Plus also the data was confidential and it was a real-time client data, so that cannot be exposed to other people. So that's why I'm using this free data or open data source, which can all easily be downloaded from Kaggle kernels. So here what we are looking for, this data is basically tells you about whether people have I would say kidney diabetes or not. So it is from National Institute of Diabetes and Digestive and Kidney Disease. And here we are simply going to predict on the set of features or set of values whether a person or a patient has diabetes based on certain diagnostic measures which are included in data set. Okay, like I'm going to talk about the data set in detail also, but basically our dependent or target variable is, it's a categorical variable, yes or no or 0 1 or 1 as a label, whether a person or patient has diabetes or not. Okay, this is our overall objective. So these are nothing but some dependency I'm importing, and these are the normal libraries we use, like pandas for data augmentation, data transformation, EDA, and scikit-learn is the your go-to library to import any kind of model. Okay, maybe linear regression or logistic regression or random forest or anything. Most of the things are implemented in this scikit-learn Python package. So this is going to be really helpful for any data scientist. So we use model selection for train test split. As I told you about, like you divide your whole data set into 70/30 or 80/20 split to create a dummy train and test data set, one for model training and one for model inference or testing. Okay, and then you import your logistic regression model from this linear model. Okay, and from this linear model also you can import linear regression also. Okay, and the matrices I'm going to talk about it. Basically these are evaluation matrices on which you will check or confirm your model's performance, which I'm going to talk about it. C1 is for Seaborn is for visualization, and matplotlib also for visualization to create charts and bar plots and those kind of technique. Okay, so let's load the data sets. So here we are going to pick up these are the column names, and these are the main column names we are going to pick up: pregnant, glucose, blood pressure, skin thickness, insulin level, BMI, body mass index level, and pedigree. Basically, it's a diabetes pedigree function. Okay, and what is the age of function? A label whether a person has diabetes or not, because this is a supervised modeling technique. So in training, we are going to hide these labels. Basically, these are going to be outcomes. But why we are having these labels? As I said, it's a supervised modeling technique. Okay, so we are not going to supply this label or target variable in training. Rather, we will keep it in prediction or test data set. And whenever the prediction will be done, basically this label will be predicted as final outcome of our training. Then we will compare with the existing data set and another predicting value. On that basis, we will determine how our model is performing. So that is why it is called supervised modeling technique. Here we already know the labels of the data. Okay, so let's load the data set. So I am using Panda SPD. So this is the function to read CSV files. There is read underscore Excel function is there, and there are Excel writer. There are multiple packages are there to read different set of I would say data files. And so basically, read CSV help us to read CSV or comma separated files. And here I am passing the name of columns from this list. Okay, so only these columns will be loaded from our CSV file. So let's check. Uh, so what head function does, it gives you top 5 rows of all the columns. Okay, so here we could see simple, we can expand the row, or we can see bottom of our data set also. Okay, so you could see these are the values. This is how it looks. Glucose level is there, blood pressure, as you might. So these are quite common feature which are most of the people are aware of, because these are health related stuff. And age of a person, body mass index. So on the basis of all these feature except till here, we are going to predict whether a person, one means he or she has diabetes, zero means they don't. So this is our target or dependent variable. Okay, and I will show you few more techniques or stuff which you do, like let's see, pma dot describe your data set. So what it does, it gives you few top stats about the data sets. Count how many rows are there, how many values are present in this individual columns, how many unique values are present in these individual columns, and top value plus frequency, how many times a particular value is coming at, plus it also gives you mean, max, standard deviation. Those kind of steps are also generated. Plus you can check the data type of also. So for that you use info. So these are standard things. Okay, see, so it's a pandas data frame. Okay, and there are 769 in total entries or rows, because pandas index start from 0, so that's why 0 to 768. And these are the name of the columns, and these are all not null columns. None of the column contains null values. Okay, and their data type, all these columns are object, basically, not int or fraction or fractal or those kind of, or date time. So this is how, these are like basic techniques. These are basic technique things you do to see how this stuff works. So you might have seen when we loaded the data, this is also loading the labels of those columns. So here we are skipping the first rows basically. So again, these are the options you get in the read CSV function. skip it and let's see again. Okay, now you don't have those stuff. Okay, let's see the shape of it. 768 rows and 9 columns, and these are the column names. Okay, now selecting the feature for, so as I told you, we are not going to use the label column, this one, for our model training, because that is our target column. We don't want to, we should not use our target column in supervised technique for training purpose. So let's select feature columns. So feature columns, I'll pass name of the columns in a list. Okay, and I'll create X as my independent variables, and Y will be my target or dependent variable. Okay, simple. So we can see that X doesn't have target variable or label, and Y is the target variable, which is basically a label. 1 means yes, person has diabetes, 0 means otherwise. And length also you can see 768. Okay, the data type is 764. So now splitting the data into train and test setting. So as I told you, this is a function which does it for you, which is a already developed function which we imported from sklearn itself. So it's a train test splits. Here you supply your independent data sets or training data set. Y is your target or label or dependent data. Okay, test size, how much data you want to label it or segregate it, which is not going to be used in training. And so you can suppose here they are passing 0.25. Let's pass it, I would say only 20%. Okay, 20% will be test data and 80% will be your training data. And random state is 0. You can keep it anything, maybe 10. So what is random state? So always remember, random state in every algorithm or modeling technique, whether linear regression, support vector machine, random forest, XGBoost, this is one of the critical hyperparameter which you have to set. And value could be anything, but many a time there are random state which also help you to improve your performance, model performance. So what they do, suppose I want to train this model multiple times. Okay, so if I am not setting the random variable value as a constant, every time model is going to be going to generate new values every time, or your output won't be consistent. In training it will generate other output, in inference it will generate other output. So basically what random state does, it keeps the state of your model stable or consistent throughout the training. Even doesn't matter the way, how many ways you are passing your data set, and in how many batches you are passing your data set. So basically it gives you consistency, and basically it helps you to reproduce the results which you have generated via training or when training your model in inferencing or real-time deployment. Okay, so always remember to set random state as some constant value. Okay, so let's create X train for training, X test, and Y train is a training, and Y test for testing. I hope this makes sense. X is like told you for training purpose, and this is dependent independent variable. This is a independent variable. So we have already segregated in into 80 and 20 ratio. It is for training, 20 for testing. So let's create it. Display the shape of individual data frames. These are basically, you could see 614 rows, 8 columns, and 614 rows. It's a simple vector, or I would say numpy array. And here in test you have 154 rows. Okay, this is training, and here this is your test data. So now train your model. So we are going to call this, initialize the logistic regression model. Okay, LR, and we are going to fit our train data set in our logistic regression model. This is our independent data set. This is our target or labeled it. data which we want to predict. Okay, so we will fit the model. So fitting the model, basically it will learn its characteristics, its relationship, how it works, how different features are impacting the value in generating the target value or target data set. Okay, so that's why we do fit. Okay, so let's do the prediction and how it works. See, so what I did, I used the predict function with x test, which is our test data set, or 20% of our entire data set, and this y pred has all the value as a dependent variable or predicted variable. 101 means the person has diabetes, 0 means the person doesn't have diabetes. So this is how your prediction are going to look like: 10101. Okay, because it's a binary classification problem. Either it's 1 or 0, yes or no, true or false. That is called binary classification problem. Okay, and now evaluate our model. Now you have generated the prediction, but how do you know how your model is performed? How has your model performed? So you have to evaluate your model's performance. So here there is a thing called confusion matrix. Most of the people, I hope, knowing about it: true positive, true negative, and those kind of thing. So here basically it's a true negative values. So let's generate this. See, so confusion matrix. So we'll pass y test actual values and y pred predicted values. It's already built, so it generates confusion matrix in this form. So this one is a true negative, this one is a true positive. True negative means we truly predicted these values, or these percent, these many people don't have diabetes, 88. True positive, these many people have diabetes and we predicted it correctly. Okay, this is false positive and this is false negative. Okay, this is false positive means we predicted 7 people have diabetes but they actually don't. Okay, and we predicted 29 people don't have diabetes but they in reality do have diabetes. Okay, so why we are talking about these terms? So basically there are matrices like accuracy, precision, and recall. So we check accuracy normally with classification data set. When your data set is normal, when you deal with highly imbalanced data set, like predicting bank fraud, or like it's going to rain or not, or like maybe which in production which is a faulty product. So these are rare events, right? So for that you're not going to have too many data. So with accuracy you cannot measure the performance of your model. Okay, so this is how so then comes your accuracy is formalized like this. Okay, but as I told you, then you have to deal with precision and recall. Okay, precision is true positive divided by true positive plus false positive, and recall is true positive divided by true positive plus false negative. So what is exactly, let's also generate first. This is 76%. So we were able to predict 76 values or 76 people correctly out of 100 people that they have diabetes. So what I was talking about precision and recall. So precision, as I said, how many people you predicted correctly, and recall is basically whatever the people you corrected, whatever the people you were able to predict were actually having diabetes. So why these precision and recall values become critical in scenarios like in the case of cancer detection, right? So in this scenario you need higher recall. You cannot have low recall, because you want to be sure that whatever and obviously out of maybe 1 lakh people or 2 lakh people, only 5 or 10 or 20 people are going to have cancer, right? This is very rare and highly imbalanced data. So their accuracy is, obviously most of the time you are going to predict they don't have cancer, but that is not your objective, though accuracy is going to be more than 90% or something like that. So here accuracy will be a misleading metric to evaluate the performance of your model. So you use precision and recall. So in this scenario, you will be requiring higher recall. Why? If recall is not higher, around 9.9 or 90%, might happen. You predicted 5 people have cancer, and you start giving them, chemotherapy and heavy dosage of drugs, which may actually have deteriorating impact or effect on a healthy person who doesn't have cancer, and plus it's going to cause them a bomb. So just imagine, it can have a grave, outcomes. So in this scenario, how many values you predicted were actually true, that is called recall, has to be higher in cancer prediction or detection. So in this way you work and set this matrices for your model's performance as per your business requirement, as per your use case, as per your data, whether it's highly imbalanced or normally imbalanced or a normal data set. So on that basis you decide. Plus there is a thing called F1 score also. Basically that is a harmonic mean of precision and recall, you know. So I guess we are done for today, and this was my presentation. Have a great time and be safe. Thank you so much. Bye bye.